Welcome. My name is Aaron Munsell. I'm joined by Eric Karstead. Today, we're going to talk about empowering resilient systems and how to improve your error handling inside your iPaas. So, first off, let's talk about why EDA and error handling. First piece that I like to touch on is we want to make sure we future-proof your investment in EDA. So, if you're always chasing errors and you're always trying to augment your error handling, really, you're never going to be able to have time or energy to handle the new things coming down the pipe. We also want to talk about resiliency. So as errors happen, we want to make sure they don't propagate across other error systems. And then also we want to make sure that when errors do happen, because they do happen, you're able to, number one, recover from those, but also empower your development and support team with the tools in order to handle that. And last but not least, we'll talk about error management. So we'll talk about this a bit more later on, but really, if you just log out every error and everyone gets told that everything's a problem, everything is going to be ignored over time. So this is also going to lead you to some organizational and product success. So inside this, we're going to be talking about a case study. We call them ABC Logistics, even though this is a fake name, is a real company we did do work for. They are an international logistics provider. They have a very complex environment where they have about 175 warehouses with more and more coming online all the time. And the problem we're trying to solve for them was we're going to make sure that each warehouse had the right master data to make sure that we are billing the clients effectively, essentially one bill for all the warehouses. And then also make sure that all the master data, as in the line items and the price and the costs, were all being uniformly sent out to all those warehouses. So you understand there's a pretty big problem. So the solution we came up to is that we decided to move them to an event-driven architecture. And we wanted to make this with a very robust error handling system to make sure that the data was always consistent and was delivered on time. Really, they trusted us with making sure that this happened in such a way that, their business is not going to fail. They're not going to have late billing. The billings are not going to be disputed, right? So we wanted to make sure this handled in a very, very robust way, and then they could scale up as they got to more and more warehouses. So we're here at a Solace conference. Let's talk first off why Solace is great. So we chose Solace for this. A couple of things I want to touch on. Number one, we chose it because it's purpose-built for EDA. That's the reason why Solace is great. It's asynchronous. We're able to fully decouple the upstream from the downstream applications. What this allowed us to do is to really effectively manage the work being done. And it allows us the agility in the future to add more consumers or producers. It's cloud and protocol agnostic. What this provided us from the business perspective was the ability to have some agility in the future. Maybe there's some new IoT sensors coming on. Maybe they wanted to bring in some time series data. We have the ability to now route more data through this. One big one when we talked to the client about this was addressing non-functional requirements. It has to be reliable. We have to be able to recover from a disaster, and we have to scale with our business. And what this allowed us to do is really build a very flexible and composable application network that we are able to grow with time. But EDA introduces new challenges, right? So challenges we'll talk about is, number one, there's no human interaction. So no one's going to call help desk when something fails. We don't know that these things happen. Asynchronous failures, right? Errors in message delivery and processing can happen at multiple steps. And we have to really make sure that we have enough power and information to detect where that happens and how to recover from it at these different steps. Data consistency. We want to make sure that the data is eventually consistent across everything. And it requires some pretty robust strategies to make sure that that happens. We wanted to make sure that error propagation didn't happen. So an error happens in system A, we don't want that same wrong data to propagate across the rest of the enterprise, causing more issues. And from a project perspective, this really led to some pretty heavy testing requirements. So with a typical request-reply integration pattern, we moved to EDA, and that required us to do at least 2 times more testing of everything to make sure that we have everything looking right. So here I'm going to pass it over to Eric to talk a bit more about what we really did and what we built to satisfy these problems from the client.
All right. So as with any integration application, there are some standard mechanisms for handling errors. And with EDA, there are some even additional capabilities that are provided by the infrastructure, such as Solace, to be able to manage errors. So we have some options. Some of the really basic things is if we get a bad message, well, we can discard it if there is some acknowledgement mechanism back to the sending client. Eventually, if it doesn't receive it, it could resend the message. We have the ability to pause uh, the inputs and allow our downstream systems to eventually become reconnected or resolve connectivity issues. Um, we have the ability to retry, on a cascading time where if it will retry in 60 seconds and then in 2 minutes and then 5 minutes, but eventually we're going to run into a problem where we can't handle that message and we want to do something with it. And one of the things that you can do with an EDA architecture is you can set up your dead letter queues so that I take that message, I can't process it, I'm going to move it over to a queue for somebody to look at later. You have also the ability to reach into your stream of messages and potentially replay messages. You can build circuit breaker patterns to block the inputs while you're resolving downstream issues. And then for even more complex event-driven applications where you've got a very distributed application network, you can look at doing something like the saga pattern, which tracks your messages across the various steps of your application and the ability to view those messages. But typically a Saga pattern isn't out of the box. It's something you're going to have to build yourself. For this particular application, it was an iPaas solution, both Solace and MuleSoft. And we did it because it gave us a unified mechanism for handling both APIs and events and messages. We had, real-time responsiveness. So when data was updated in the centralized system, it would be typically in the downstream systems, warehouses, all 170 of them within seconds. So there was a real-time responsiveness. We able to scale to very complex environments. We said we've got currently 170 warehouses where we're pushing data to. We are able to scale to 1,000 if needed or more, simply through using message topics for the data to be sent to, and building connectors that talk to those particular new endpoints. Event-driven is very simplified in Solace, and with MuleSoft, having an out-of-the-box connector for the product, it really simplified our development, and it provided us edge to enterprise connectivity. So many of the events coming into the system are coming through either a REST API or an FTP service where we're processing a batch file and updating data and pushing it out to where it needs to go. So we have both the ability to secure our edge and also deal with the messages in a reliable fashion. So, as I said, that EDA introduces some challenges, but using Solace, we can leverage the capabilities to actually resolve some of those challenges. So, there are some things that you might want to do is if I'm going to create something like an audit trail of all the events, I want to be able to say when I ingest the message, the first step of the process, I want to assign it a correlation ID at the start of the process, and I want to attach that to all follow-on messages and any event logging, both in your logs and in your audit trail. You want to attach that correlation ID so you can track it from end to end. You want to publish events to the audit bus, the audit topic, when you read a new message, when you successfully process it, if you're going to publish it to the next step, so that I know that my next step should be receiving something, and then if I have any errors in the message, I want to log it off to the audit trail with the robust error information. And that's really going to enable me to implement the saga pattern. Wherever possible, if I don't have sensitive information within the message, I can also publish the payload to my audit trail. This really aids in resolving issues, so that the consumers or the stewards of the system can view the data and see where there are problems in the data when there is. And I can also replay those messages from the audit trail by injecting them back into the step that they failed into, because I do have the payload there. So let's say a connectivity issue is resolved. I can take those messages, mark them for replay, and send them into the appropriate step. And one of the really bigger benefits that we got was that we have the ability to now define the alerting and notification of events that are important to the business outside of the actual application steps. I have a centralized alerting system. It can send to pagers, emails, Slack, Teams, and the rules to where that goes is defined in our audit solution. And I can take all of that coding out of the individual processes, and then it allows us to develop faster and provide a more flexible alerting system. And then one of the bonuses that we got, which addressed the testing issue, was the fact that because we're capturing the payloads in the audit trail, we're able to replay all those events into a lower environment and heavily test, tens of thousands of messages that are close to real data as possible in lower environments. So this really improved the quality of the solution by replaying those messages into lower environments. So this is a simplified diagram of the actual solution. On the left side, we have the actual flow of the events. Solace is the message broker between all the event processes after you get past the edge. And so that gives us reliable delivery, routing, visibility into where our message queues are at. And it allows us to build the system APIs to talk to the back-end systems through the protocols that are needed, whether it's a a SOAP call or a REST call or a database call. But it guarantees that we have the message flowing from source to target. And then on the left-hand side, we have our management and audit console solution. And again, that's enabled by Solace, where we publish those events at the various steps when we read, when we publish to the next step, so that we have a complete audit trail of where the data is flowing. And then we have a user interface, an audit console that allows us to look at the data. We have influx time series database and Grafana to track metrics and data flow. We can see what's a typical day's data flow versus an atypical. And this really helps us give us visibility into the system. So what do we get with the audit console? We get a reusable solution to search, filter, inspect, replay, audit messages of our solution. Currently, we're talking about one application, but this now use has gone to 3 applications, and we have plans to do it with additional applications because it's really helping us get to the root problems a lot faster. We have a UI that allows us to configure routing of messages. And we get also within our UI an application network health. So what is the status of all the components of our application network? We have handling events in very complex application network. Again, hundreds of destinations, and we can manage that, reduce it, filter it. We have the configurable alerts and notifications. That isn't just on errors. I mean, errors is the primary solution, but we have some notifications when we have additional notifications for particular customers, so that we know, because we have the payload, we can say, oh, we have this type of error and it's for this particular customer. It needs to go to this person as additional notification. We can enrich our events, our error events and alerts with additional AI analysis, and we'll get into some of that a little later on. And we have the application isn't that complex to build this. It's composed of a repository for the messages, a user interface, and a process application. So it's not a huge lift to implement this in the environment. So this is just a quick screenshot that allows us to go in and search for events over a time period, on different criteria, a different status for a particular topic, and filter on and look at the message flow, and sort and then filter. We've got hundreds of thousands of events, so we need to be able to reduce that. We don't want to bring it all to the client, but once we do bring it to the client, we can filter it. And then on the next slide, we can actually drill down into the message. We can look at where it happened, where it was going, look at the actual content of the message, and we can replay either an individual message, or from the previous screen, we can select a batch of messages and then replay. Let's say there was a connectivity issue to a particular warehouse system. And once that's restored, we can go in and say, okay, just resend these now to the solution. Next slide. Right.
Thanks, Eric. Let's just talk about the next steps, right? And so we just talked about how we can effectively track all the errors, we can cut away the noise from the signal, right? So we no longer talk about sending every error out. We actually are able to make sure that only the needed errors are sent out or notifications so that we don't tire people. And we're talking also about what we can do about next. So let's talk about complex event processing in AI. So this really allows the groundwork for proactive automation and preventative maintenance. So we're able to predict trends, automate responses, and enhance decision making. The idea is that we have data now, and hopefully that data grows over time. We can plug this into an LLM of some sort to get even more insights. The other thing that we're talking about going hopefully short term is augmenting our error handling with AI. So the first thing we're thinking of doing is streamlining our IT help desk process. So we're thinking about like a world where this AI could effectively augment or replace your level 1 and level 2 help desk, or less than the amount of people you need for that. So they should be able to look at an audit trail, figure out where to replay things, do that kind of stuff. The other piece it could do is arm your level 3 help desk people with more relevant information so they spend less time looking and more time fixing it. The other thing that we're looking at doing is, augmenting our agentic AI with this data. So imagine a world where our AI agents are able to see this data, go from a customer inquiry all the way to understand what's happening in the middleware in the back end, and potentially even the ability to self-correct. So once again, replays, retries based on certain items. So as a review, we talked about the logistics company we did some work with, very complex environment. Want to make sure the data was there effectively, really quickly to facilitate billing, right? So they want to make sure their bills go out on time, no delays, and that they're always correct. We're talking about 170 up to thousands of warehouses that all have different systems. All the systems coming in have different protocols and requirements. So we're able to use Solace and EDA in such a way that we're able to handle the spikes of data effectively. We can scale to wherever they want to take their business, and we can know that their data is effectively always consistent, and that there's no real propagation of errors that happen from our work that essentially cause other systems to die. Anyways, thank you so much for joining us. My name again is Aaron Wenzel. I was joined by Eric Kirsten. Here's some information about Bits and Glass. Eric and I would always love to have more discussions if people want to. Stay around for the Q&A or reach out through any of these items.